The sine law, or also called law of sines, is a relationship between lengths of a triangle and the angles of a triangle written in this form. As you can see, it has sines, so that's why it's called the sine law. And in some textbooks you might see not this version but the one with where every fraction is taken the reciprocal of. So instead of that form, you might see as sine A over A, sine B over B, and sine C over C. Okay, what I want to do is to explain why this law of sines does hold. And to see why it holds, first you need to make a circumcircle. So some of you remember how to make a circumcircle. The way you do it is you take the perpendicular bisector of each side, and when the perpendicular bisectors meet, they meet at a single point, and then starting from here you can show that the distance from this point to all the vertices are the same, so you can draw a single circle like this. So this single circle passes through all the vertices of this triangle. Now once you have figured out the circumcircle, the next step is you have to draw the diameter that connects the center of the circle and the point B. Now we're going to call this as A prime for a reason that will be clear a little later. Now what I want to do is then connect A prime to C and get this. And it's a property of the diameter that any angle that you draw with one side being on the diameter, this becomes a right triangle. So I want to show that, say that this is a right triangle. And moreover, we also learned from the circle geometry that this angle and this angle will have the same angle because the measure of this arc is the same for both. So this angle here and this angle both both are opposite of this arc, and since they have the same measure, these two angles must be the same. So when I say sine of A prime, since A prime and A are same angles, that's the same thing as sine A. Now we're going to use the SOHCAHTOA. Let's call this diameter the D. D will be the length of the diameter of the circle. And now we're going to use SOHCAHTOA to say sine of A prime is opposite of this angle A is this length, A, over the hypotenuse of this right triangle is D, so that's what we have. And then what we get is we now replace sine A prime by sine A since they are the same thing. And we multiply by D. And what I want to do is basically solve for D because I want a formula for D. So I find that D, which is the diameter of the circumcircle, is equal to A over sine A. Now this is actually a proof of this law because of the following. There was nothing special about this length A and angle A. We could have, instead of drawing this line here, we could have drawn a line that's connecting A to here. And if we make another right triangle this way, then you'll see that this angle and that angle will be the same. So this B prime will be same thing as B, and using the same kind of logic, we can use this to show that this is same thing as B over sine B. And also in the same way, we can draw another one coming from C, and you can show that it's C over sine C. So we know that to get the diameter of the circumcircle, you need to calculate either A over sine A, or B over sine B, or C over sine C. And since they're all equals to the diameter, so they must be equal to each other, right? So I'm trying to say that you could have shown that D is B over sine B, or D is C over sine C, and you could have seen that D is A over sine A, just like how we just did. We just show that this is true. But once you show that D can be computed in these three different ways, since the diameter of a circle is same no matter which way you draw it, all of these values will be the same. So that's why the law of sine is true.